lines versus using UTF formatting or decoding, encoding. You will have those issues. Lists are a beautiful concept. It's just like an array, but it's just a list of values. You can have lists within lists. You can have objects within lists. You can have integers. You can have strings. It's just a representation of an unordered list of items, or ordered. A set is, this is what I use quite a bit, where you'll take a list of a number of different items and then convert it to a set, and then it just basically makes sure that you only have unique values in that set. A dictionary is, I tend to think very visually, so I literally think with a dictionary of a word in a dictionary and the definition next to that word, and saying dictionary, giving it a word, and then it coming back with a value for that. So the one represent key, or the numbers represent keys here, and then the characters or the strings represent their values. So you can ask, I am a dictionary for number 1, and you'll get back blah. I don't believe in PR, obviously, by the way, that was a joke. But I thought it was a good example. Not to say I don't believe in PR, I just don't. It's an outdated concept, obviously. For loops, just some examples of iterating over a dictionary and iterating over a list, where you can see that for the list, you have to be really careful, because iterating over that starts at 0 and not at 1. So new programmers or new developers will run into issues not thinking that it actually, the first index of a list starts at 0. And then you can see how Python has an amazing function called enumerate, where you can just wrap any list in that function, and it automatically pulls out the index and it pulls out the value to make it really easy to loop over and do whatever you need. List comprehension is something we use when we do natural language processing, because it's really easy to take a string that's been transitioned into tokens and say for or A for A in string or list of strings, if not in stop words. So that's one very common thing you'll see in natural language processing, is using list comprehension to remove words from a list of tokens. Lambda you'll often see, which are just very small functions that take some values and just perform an action. And then you can see full-scale functions, where you have here, we've defined a function named showPR, where you give it a number, and then it basically assigns the dictionary result of that number location to the PR, and then returns PR. So just the idea of creating a function that you give it certain values and it returns back. This is very glossed over. There's a lot of different nuance with using a lot of these, but if you take some time and just learn to understand the mechanics of most of these pieces, you can use them as building blocks for putting together any kind of development projects in Python. Important libraries for me are Pandas, Requests, Beautiful Soup, and Google's API client. Pandas, again, I think very visually, so I think of Pandas almost like scriptable Excel. It reads and writes to CSVs. It also reads and writes to Excel. I use normally CSVs. And you can iterate actions over millions of rows. I probably use the apply function of Pandas more than anything else. But you can see here where we've imported Pandas as PD. That's a common way to import, and assign it just a smaller identifier, and then we read a CSV containing a list of URLs, and then we print out the head, which in this case we've asked for 10, by default it's 5. Pandas is also subscriptable by columns, where you can see here that we've asked for the URLs column of the data frame and to give us the top 5 results there. You can also sort and filter Pandas columns really easily. So you can see here in our data set we have URLs and we have their position, and you can really easily say to give me return the data frame URLs where the position is less than 5, and then we want to turn that into a list so that we can just iterate over those URLs. The final thing is the apply function I was talking about earlier, which in this case, you know, we're taking each row from the Pandas data frame, and then we're assigning the URL column value to the URL. This is a very simple domain parsing. There's better libraries for this, but we're just splitting on the forward slash, taking the second value at or third, and then assigning that value to the row domain. And you can see after we apply that and hit head, it's now applied domain to each of them. So you can imagine taking a list of URLs, crawling the URL with requests, which I'll go over in a second, pulling the status of it, hitting an API, pulling some data from there. There's a lot of stuff you can do with Pandas to operate over data frames and pull a lot of information about your seed data set that you're sending into it. This is a really quick video. Just wanted to show how easy it is to use GitHub to generally train yourself on anything. This is I think it's a minute. That's a data lab demo from Berkeley on Pandas. So basically I've downloaded it from GitHub, put it in and unzipped it into the Python repo, and then you have a full annotated notebook on Pandas where you can run the cells and it describes what each of them are doing. So this is the way to learn Pandas and actually see it in action and play with it. And Jupyter gives you a nice way to kind of go through and test and run each of the different cells. Requests is another one that we use a lot. Requests is basically a library that allows you to load URLs. Most of the time we use Git, but you can use Post, whatever. It's often used with a parser like Beautiful Soup. So generally we'll use requests to fetch a URL. Sometimes we'll send a header with it that's the Googlebot user agent or the Googlebot mobile to test whether that server is responding correctly based on the user agent. And that's one of a million things we can do with it. But anytime you need to check a URL, whether it's 302, whether it's 404, any of the status codes, you need to pull the content from a URL. Requests is what we normally use. There are other libraries for that, just I like requests. And like I said, requests, basically you can request a URL and it'll bring back that raw HTML.
GPS signal lost.
Beautiful Soup is very similar. I would think of it like jQuery, where you can actually query the DOM and say, give me all the 8 elements from the page, or give me the title, or give me the meta description. It's basically what you use to get the stuff from requests and actually do something with it in terms of extracting data out of the page. It does not render JavaScript sites. There are some really good Lambda functions like Chromeless, which is one. That's a Lambda function that you can load up to Amazon Lambda, and it's basically a headless Chrome browser that you can hit that, it'll render and send it back, which is great if you need to render and get the content back from sites. But Beautiful Soup is great for gathering data. I think we can run it for collecting, zip code and city-state data, millions of rows of data for several projects across certain sites. Many libraries use Beautiful Soup as their web extraction functionality. So even if you're using other libraries, you're probably still using Beautiful Soup that does any kind of web extraction of data. And I wanted to show, I just did a really quick scraper here over the weekend. But what this does is it just hits Google News, and then it pulls all of the URLs from Google News and splits them, and then checks whether it's an article, publication, or story. So in about maybe 5 minutes of coding here, we can pull something that's mildly useful, and that it tells you, with respect to the day, the number of publications, the number of articles, and the number of unique stories that are posted to Google News, which is something you could track over time and could have some use. The final one is here is Google API Client. Google has a tremendous amount of APIs that do all kinds of amazing things, so that's beyond the scope of this, but I would take a look at them. They have image recognition libraries, it has stuff for local, it has stuff for Google, obviously Google Analytics, and it has search analytics. There's so much data that you can get out of Google. If you're an SEO and you're interested in Python, I would learn the Google API client and how to use it. So it's a lot of code there to connect, but the reality of it is that that code is copy-paste. You copy-paste it into Python, put in an API key and secret. That's literally the hardest part of it. And Google has, and on Github, has some really nice sample code that you can use for running all kinds of queries with search analytics. Yes?
I found it, and I use a lot of open source, but I found Google's API to be very confusing because they had multiple levels out in the wild, so to speak. And I pulled in one and started using it, and then I was looking for a different part of their client API, and
is that through Python?
yeah, using in Python.
I mean, I'll tell you that I find documentation on Google hard, but normally I will go, like you saw with the thing for Pandas, I'll go to GitHub and I'll search analytics, and I'll get code that's already been done, and then I'll see how they did it.
Okay,
and then
so
I'll
you were
copy
using
that.
somebody else's project that you...
I use a hell out of other people's projects. Yeah, oh yeah. So anyway, here for this, you can see that this this webmaster service URL call sample is probably copied from somewhere that I found on GitHub or whatever. But you can see here that I just copy pasted the API client information, ran it, and then ran a simple execution against Google's webmaster service, and then I just hit URL errors, right? I just call that within the cell, and it gives you what the output is, and then you just have to trace it there, and you can see that there's a dictionary, there's another dictionary, there's a list, so you really just have to trace out how to call the items, and you can see here that I'll hit it, URL errors, look at what the response is back, and then use that response to kind of map how I pulled the data from that API. Or you can look at their sample output if they have that, but rarely they do. So getting into automation, anybody have any questions on any of that before we go? So this is my standard process for automating. I have an idea about something or an expressed request. I'll go to GitHub. GitHub's the first place I go to because 9 times out of 10, somebody's already started working on that, and it's there. You just have to get it downloaded and then tweak it to what you need. So copy paste it. I'll cuss a lot. I'll go to Stack Overflow and research about 20 problems that I experienced. And then I have the code and I'm hitting up my team members, hey, look at this. So the reality is that like there's no developer, or maybe a few, but I would say the majority like have the same problems as everybody else from a development standpoint. No matter how long you've been doing it, there would not be, like I'll post things on that I've had issues with that seem like really silly issues, and then I'll search for an answer for it, and I always go back and I put that answer for someone else who's having that same search, and I'll do a really good answer for them with code and everything, because every now and then you get that guy or girl that you know, you helped, and they're like, thanks, I was searching for this forever, and you get the email from GitHub or whatever. But no matter, and a lot of times those are experienced developers that had the same problem you did a year later. So anybody that's new to coding or scared to get into Python, like we all struggle. We all are on Stack Exchange. We all think it's going to take an hour and it ends up taking 5. It's just the way it is. One of the reasonings why I like automation is this formula here, and it comes from something I heard a long time ago that says, today I want to prepare my future self for success. And this is the way I see that, in that, you know, if I have a task that takes 3 hours today, can I spend 10 hours today and save the company or save myself 100 hours over the rest of the year? And a lot of times with automating things or taking the time, we joke at work about, you know, a lot of SEOs or especially technical SEOs who like to develop are like lazy. We don't like doing this, like I can't, there's nothing worse hell for me than doing a mundane task that takes like an hour over and over and over and over again. Like I just can't do it. I want to automate it. So I think there has to be a drive to automate, but I literally think about this of, well, I save 3 hours for every hour that I spent in developing this over the course of a year. And if I will, then it's worth doing it, and I'll take the time on this one task. I'll stay late, I'll get it done so that we can save that time to do other things and not a mundane task over and over again. So this is, kind of did a really quick calculation here, but you can see that if, especially in a company, if it takes roughly 4 hours to perform some task and 3 people at your organization do it, and it's a task that's done every month, and that's 12 hours a month. If it takes you 11 hours, instead of spending 4 hours to code something to automate that, like you've saved your company potentially hundreds of hours a year. So that's a big thing, and especially if you get a culture where people can pass around information like this, and they're like, oh, okay, I understand that this is going to be a commented notebook, and I'm going to understand kind of how to execute this. That's something that over time can save a lot of time internally for a company. So a few examples of automation. Some of these I've shared code with, and others I haven't because they're internal, and Marty would kill me if I did. Yep. So one of the first ones, I used to work for an agency, and we had a contractor that did all of our Google Search Console 404 link recovery. And who's done Google Search Console 404 link recovery before? It is a terrible process, especially on a large site, if it's done manually, because you're literally going through clicking on URLs to see what they're linked from. So what we did was, again, hook up to the Google API. We download all 404 pages, or all the samples that Google gives you, from, which is a lot. And then we find it also gives you the external links to those pages. So we download all the 404s, the links that are pointing to those pages. We filter out any links that are coming from our site and only get external links. Then we use requests to go in and check each of those links and make sure that there is still a link to our site. And then we also have some other filters like .ru and .pdfs, or things that is not really, I don't know, I don't think we have PDF, but we have like .ru and some other sites that just tend to be kind of garbage sites we don't want to come back from. And then we basically do all that and output a list of URLs, the page they're linking to, the page is linking, and then we can just really quickly manually review that and then put together a recovery. Sometimes we have enterprise clients, and a lot of times they might be on other client-owned domains. So otherwise we could just output 301 old URL, new URL redirect, and then send that to put into htaccess. But a lot of times we need to review it and make sure that there aren't links that we could just have them change, which is better. But that's a huge time saving, especially if you have an internal SEO that's doing that manually in Google Search Console. Reddit mining, this is a really cool one. This is a different library, but it's a library called Crawl. And this is one that I have a link here in the presentation. It's really cool to play with. Basically you give it a topic, and then it scrapes Reddit looking for question-answer pairs for that topic, and it'll output them in a list. You can actually use this to train a chatbot. There's a number of different libraries on Github that take in question-answer pairs and already have the training and the prediction models set up. So you can have a lot of fun with this. That's a cool weekend project, but it's also good for looking at topics on Reddit and seeing kind of what's trending and what people are talking about, what questions people have with respect to a particular topic, and maybe even a narrative for a particular company. So really helpful. And you can, for some topics, it'll bring back 1,000, 2,000 different question-answer pairs, which is great. Sitemap sampling, like we have some clients with upwards of 300 to, I think one has 1.2 billion potential URLs. So obviously that's a lot of sitemap files. So sitemap sampling is something that, if we want to do cache checking, I don't want to throw in a 50,000 URL number of URLs. So this gives you statistically significant random samples of sitemaps that you can run through and do cache checking, do monitoring, or do whatever on. Maybe you want to run all the URLs and then just track if they're all similar, and you can impart some type of the keyword utilization from the page or the keyword topic from the page. You could sample your sitemaps and then parse it back to a keyword list that would give you a representation sample to track and rank tracking for a large number of URLs. I don't know if that makes sense. It made sense to me. This is really cool. Who's used Google's Search Console API now that it has 16 months of data? It's fantastic. This is one that we just started using, and it's great. It literally gives you 12 months of data, and you can see that here we've pivoted it by yearly impressions, monthly impressions. We have some specific filters that we're using on that, but you can see here is monthly clicks by query, and then another one is position by query, which is pretty fantastic. And this one actually allowed us to really quickly spot. You can see the term there that goes, don't have really a row there, but you can see it's 28 about maybe 3/4 of the way down. You can see where it was ranking. Interestingly enough, the one that has a row of ones there, ranking 1, and then goes to 100, falls off, is where another brand that started ranking for a misspelling of our client's brand, which I was like, what the hell happened there? And that made sense. It was interesting. But it's really good to give you a really quick glance of your SERPs and go up and down and see where you may have hit or missed recently. Internal linking, all of those different little boxes on the right are one process that we use internally for internal links, where we pull 3 months of Search Console data. We developed a metric in-house that calculates weighted impact of moving up a couple of spaces for a particular keyword. From that, we select the target keywords that we want to go after. Then the tool searches Google for that query and site : the domain. And those are all relevant pages from your domain for that particular query. Then we go through each of the resulting pages, and then we use n-gram analysis and similarity analysis using word vectors to find the word on that page that is the closest to your topic. And then we output that, and it's basically saying that, you know, you have this phrase, these other 8 or 9 or 10 pages on your site are really relevant, and then here's a term within your page that you may be able to switch out to your anchor text and point it back to your page. And the nice thing about this is that you output it, you run the process, and then you also have that and you can track it over time. So it's a really good automated process, but this is run from one notebook that uses a lot of the libraries that we talked about today. We also published in April a forecasting notebook that uses a tool set from Facebook called Profit that basically takes 1 year, 2 year, 3 years worth of analytics data, and we'll actually do a forecasting model out into the future with an uncertainty interval and some trending and yearly, monthly, or yearly and weekly seasonality, which is great data. But the blog article is linked from there, and we also have a collaboratory from Google Notebook where you can actually use the code yourself. It's pretty cool. Trending pages. This is one that uses Google Analytics, and this is in, I'm going to share a download link where you can download all of these examples, or a lot of the examples that I've gone over, and this is one of them that's in there. This uses a library called Google Analytics, but it basically hits analytics for, you basically give it a series of years from, let's say, 2008 to 2018, and then it goes over each year and then appends a column to a data frame for each of the year and puts the page values. But it's a really quick way to take just a list of URLs that you're interested in, seeing kind of the trend history of that URL over time, and then using analytics or API just to pin that in a really interesting way. But some of these things, and the reason I shared them is, before I go to the resources, is these all give kind of toy examples of using not only the Google Search Console API, but also the Google Analytics library. So they should be pretty straightforward for you to kind of look at and just kind of trace. It's generally hitting a library, pulling some data, and then iterating with a for loop to do something interesting with the data. But you have toy examples that we'll share afterwards that are worth looking at. A few other online resources. There's a guy, Mike Levin. I've never met him, but he seems like a really amazing guy. He's got a repo called Pipulate. And it's really cool because it connects, not only does it have a connection to Google Analytics and Google Search Console built into it, but it also integrates with Google Sheets. And I think he's got some type of cron script built into it, so you can actually like automate pulling data from Google Search Console and Google Analytics, and then just specifying a spreadsheet name and a range, and it'll push the data into there. So that has to have some pretty amazing applications. The Google API client is there to look at as a link, but again, I would recommend looking up examples on GitHub. That's usually the easier way for me to learn and follow. Brittany Muller's Ma's presentation, a lot of the things we didn't go over, but we do a lot when it comes to natural language processing, machine learning, that I just thought was a little out of the grasp of this presentation. But her presentation has a lot of those kind of items. We actually helped her on one, which was automatically passing a URL to a Amazon AWS Lambda function and having it grab the content and then summarize the content and pass it back, and we integrated it into a Google Sheet. So there's some really big technologies that are going to be super helpful for SEOs, and Python's one of the main, it is one of the main platforms that a lot of that's developing off of. So if you haven't spent time on Python, I would compel you to spend more time and get more knowledgeable and keep following things on GitHub. I also have a link here of some various notebooks that I've written and have posted on Anaconda Cloud. One in particular uses SEMrush to do kind of LSI type of stuff. I don't like the term LSI, but you get the idea of what that means if you're an SEO. It also uses what's called a shingling algorithm, which is what Google uses to look at content similarity from crawl data. But it basically uses something called n-gram shingling that takes the content of your page, transfers it into these shingles, and then it compares the shingles. And what's interesting about that is that instead of paying for a service like Copyscape or can't think of there's another one that's really popular. You can just crawl a sitemap file and then hash it, and then compare the hashes and get a pretty good sense of the level of similarity between content on a particular site, or at least where the high points are, and it's very quick too. So I would definitely check that out. Finally, I packaged a lot of the stuff that I went over here into a bit.ly link that you can download and play around with. Like I said, one of my main motivations in sharing this stuff and sharing my code is I'm hoping other SEOs will join open source and test stuff and put their code on GitHub. I mean, like Mike Levin, I love the guy. You know, he's got this code, and I'm sure they use internally that he just shares out, and it's just helpful. I might not use that code exactly, but I'm sure I'll borrow stuff from it. So definitely code, share. I learn stuff every day on GitHub. It's just the more SEOs that we can have kind of doing this stuff, the easier it will be for all of us. So that's it. Thanks. Any questions? Yes.
Yeah, talk about what that whole glass architecture thing was. I want to know what that was.
No.
No. No, I want to know what that is.
We did like leaded glass
Okay.
and
Like
carved
stained glass or
edged,
something?
Yeah, stained glass for years. I did the leaded glass in Coach K's wine cellar,
Wow.
which was kind of cool. And we got to work with one of the best, really expensive glass. It was from Czechoslovakia, mouth-blown antique glass where
Wow.
they actually pull it out, blow it, lays it out. It's beautiful stuff. But yeah, that was my life for 10 years.
Wow.
But I was always a geek at heart, so yeah, it was going to happen eventually. You had a question?
Yeah. So there's a bunch of things in here that I really love, as far as being able to pull data that I can see using right now. But one of the things I wasn't really too clear on is, can you use Python to actually like do stuff other than pulling data? So here's a random example. Let's say I've got a client with 1,000 pages in their blog, right? It's on WordPress, and all throughout it are just hundreds and hundreds of broken links. Can I write a script that can go there, find all the links that they have inside all their blog posts, test them to see if they're broken or not, and then spit that out to me and tell me where the broken links are? Can I do something like that?
Absolutely. I mean, there's I'm trying to think. I might follow up with you. There's a handful of crawlers on GitHub that are coded in Python that I'm sure you can do things exactly like that. The nice thing that I like about coding this stuff ourselves, rather than running something like Screaming Frog, which is obviously an easy way to do that, is that you can kind of do extra things that help make it easier. But there's a ton of crawlers on GitHub that you can use, and then basically there should be some type of execution function of once it gets to a page, kind of what you want done with it, and you could save that to a pandas array or whatever. So absolutely. I will tell you that I kind of like to use things for what they're good for. So I don't spend a lot of time building crawlers. Like, I'm much more likely to crawl something with Screaming Frog and get a list of those errors or their original URLs, and then I might just dump that CSV into Python.
Do something with it from there or whatever.
Yeah, like you could. I mean, there's a lot of different things. I mean, there's libraries like Russ Jones did a plugin for WordPress. This is one of the first times I knew about him. He did a plugin called Predictive 404, right? Something like that, but it used Levenstein Distance, where you would just drop the plugin in and it would catch a 404. So if a 404 was happening, before it would just return a 404, it would say, okay, well, it would take the slug and then it would hit your database and see if there was another slug in the database that was within a certain Levenstein distance from the slug that was being requested. And Levenstein distance, I'm oversimplifying here, but basically looks at the character difference, order difference. I think it's the number of changes that need to be made to make two strings the same. But basically it looks at that difference distance, and if it was over 0.9, it would just go ahead and redirect you to that URL. So it's entirely possible that you could run something like that, where you get a list of 200 pages from Screaming Frog, and you get your 404s, and then it just runs through and opens, takes all the URLs, and then tries to find a URL that's a very close variant from a 200 list set. I just with crawlers, you get into things like rate limiting, specifying headers. Like, you can do that. I tend to think, how much time am I going to save by incorporating the crawling functionality into a script, or is it easier just to use that tool to get the data versus doing my own? Because really the time savings there is in kind of reviewing and finding 300 and then doing something actionable with those. So that's the part I would work on. Does that make sense?
Yeah, I appreciate you elaborating on that. Thank
Yeah.
you.
Sure. Anybody else? Yes.
So you mentioned at least one of your foils using the natural language toolkit, and I was wondering if you had used any of the other bigger corporate sentiment analysis and done comparisons, because it sounded like you were doing sentiment analysis with your own code, and I know that is a little complex.
I mean, I haven't found a good use case in SEO for, I'm sure there is one, and I'm sure somebody's sitting here right now going, boy, does he not know, but like it hasn't come up where I've been like, man, if I really knew kind of the sentiment of somebody right now, that would really help me make something amazing here. I think generally from like applications like, you know, people that have user-generated content, comments, people that are like mining social media and looking for, you know, or even, you know, mining company information from the web and trying to get a sense of overall sentiment.
Do you have a good sarcasm analysis where you can say this is the antithesis of what I'm looking for?
No. No, I mean, but it's an interesting field. It's a hard field because you can have, you know, single words negate an entire sentence, even though that it looks like it's entirely positive, except for this but. So that's a really hard field to do accurately at scale. Anybody else? Cool. Well, I hope it was helpful. Thank you, guys.
Beer 30.
Huh?
It's beer 30.
Yeah.
Yes, it is.
Thank you guys very much for coming out. Well, I think everybody can hear me. The live feed did work. So the video is already up on YouTube, Periscope, and Facebook. And we have a local copy that we'll end up uploading that's a little bit better quality than what was live streamed. So if you need to review any of that, you can check out those videos. And the links are also clear in the video, so you can go download those notebooks. And if you have more detailed questions, meet us over at Rookies. Quick show of hands, is anybody going over there to chat?
I'm going over there. I just want to be here.
So, JR will be over there. And we'll see you guys later.